All right, today we're going to go backwards from what we did yesterday, and what you have here is a set of piecewise graphs that need their equations found. Now, typically these equations need to be given names, and because I'm not creative, I'm just going to use f of x, but you can use any letter for the name of the function, and traditionally the squigglies are located there, and I'm going to put some squiggly over there on the far right, but I'll wait till I see how big my equation is before I end that squiggly. So I've got two equations on this graph, and the first one I'll start with is that parabola. So I got to find my locator point, or the vertex, which is left 1 and down 5. So x plus 1 squared and down 5. And we should check to see what the a value is. Now, because it's up 1, right 1, up 1, right 1 squared is still 1 over 1. So the a value is just 1, which I'll leave blank. All right, now let's go find the equation of that line. So somewhere we need to be able to find the slope, and I'm going to come over here so I don't confuse you by drawing anything over too close to that area. So the slope I can see is down 2, right 1. So negative 2 is my slope. And the next thing I would need is the y-intercept. Now I can't see the y-intercept, but for this one, I could just continue going up 2 and over 1 and kind of anticipate seeing it off the graph, and then up 2 over 1 again, and seeing if I can make the right guess as to what that dot is for the y-intercept. Now, if you don't like that method, or you're not confident with yourself, you could always take the equation of a line that we know so far, the slope, and plug in one of these coordinate points that are on it and solve for the b, or the y-intercept, that way. So for example, that dot there, which is 4 comma 1, 1 would go in for y, and 4 would go in for x. And that would be negative 8, which you'd move to the other side, and you get the b value of 9. So that's probably 9 up there, which I could have made a good guess on. So we did it algebraically. So that's the equation of that line, and that's both graphs. But now we've got our domain cutoff to include. Okay, so you can see the cutoff for the graph is here. The parabola went to the left of this x value, and the line went to the right of this x value. So the x value of 2 is the cutoff. That's the key cutoff x value that we use in our domain cutoffs. Now for the parabola, it has been graphed for all the x values that are to the left of 2, which means the x values that are less than 2. That's what got graphed. All x values less than 2 for the parabola. For the line, it's all the x values that are greater than 2. Because the line has a solid dot versus the hollow dot, the solid dot means we want to include the 2 for the line. Now, technically, we need to end it with our little squiggly, or whatever the name of that thing is, and we're done. Now, I've seen some worksheets where they write the word for here or if here, and some have dots. You actually don't need anything there if you just want to spread it out. There's nothing going to be graded in this center section here. But that's it. That's problem number 1. That's done. So let me slide now to a harder one. Let's go down to number 4, which is made up of 3 graphs. So we're going to have 3 equations. I'm going to name this one G, just because I don't want you to get stuck using F every single time. It doesn't matter unless it's given to you in the directions. All right, so I'll start with this absolute value graph. It's been moved left 4, so that is x plus 4 inside our absolute value bars. We have no up or down shift, so we won't put anything at the end. The slope of the line to the right, I can see, is up 1, right 2, so it's a half. That's our a value. So that is the equation of our absolute value graph. Now we've got a horizontal line. A horizontal line can be very tough, but a horizontal line is just in the form y equals a number. So here's my y for the y equals, so all I need is the number right here, and that number is the y value of this line, which is negative 2. Last thing I need is that parabola. Let's find that vertex. It's up here at positive 5, positive 5. So we've got to go x minus 5 to move to the right, plus 5 to move up, And we need to find an a value, and I'm going to find a nice pretty corner. Let's go right to here. Down 1, right 2, which has to be squared. So negative 1/4 is the a value. So we should be okay with that part. That's just finding equations, kind of tedious, but hopefully not too bad. And now we have to do our domain cutoff. So for the absolute value graph, it goes all the way till it reaches 1, or pardon me, negative 1, the x value negative 1. That's where it stops. And it goes to the left of negative 1. So it is graphed for all x values that are less than or equal to negative 1. That's how close it gets. X's that are less than or equal to negative 1 is the absolute value graph. Now the weird part, this little line here got graphed from negative 1 to positive 2. And that looks like this, kind of like domain notation that you're used to. From negative 1, x's are greater than negative 1, but they're less than 2. And since both those dots are hollow at the ends, neither one of these inequalities has an equal sign underneath it. And the last thing is the parabola. The parabola starts at 2, even though that's a weird y value. I don't care what the y value is. I just know that from 2 to the right is the parabola being graphed. So that is for all x values that are greater than or equal to 2, since it has a solid dot. And if I want to end my squiggly, you can. I wouldn't grade it if you left that squiggly off. No big deal, because it's hard to draw. You can see how terrible of a drawer I am. All right, I think we have time for one more, because I want to finish this before 10 minutes. I know these things get weird if I go over 10 minutes. So I think 6 is kind of a weird one, so I want to just talk about 6. You'll notice that the graphs actually come to a point and they connect with each other. Now, this actually looks like it could be 2 lines, and 2 lines is one way to interpret that, but I'm going to do an absolute value for that guy, since that's what we've been doing a lot in this class. So I need to give the function a name. I'm going to call it h this time, just for no reason. I've got a parabola here that has a vertex at negative 5, 1, so x plus 5 squared up 1. And I need to find the a value for it. And I can see this pretty corner. I can find my a value by doing down 1, right 1, squared, which is negative 1. Now, hopefully you knew it was going to be negative, because it's an upside down parabola. So I got that parabola. I'm going to do an absolute value for that guy rather than 2 individual lines. You could do 2 individual lines if that's how you interpreted that shape, which is fine. But let's do an absolute value since we caught it. There's no left or right shift, so inside my absolute value bars is just a plain x. I got up 3. And the slope of the line to the right is down 2, right 1, which is negative 2. So that'll be that entire absolute value graph. And now again, I've got a horizontal line, and a horizontal line is just y equals a number. The number that it happens to be is the y value of that line, which in this case is a 1. So I got 3 equations again. Now, I can't tell whether these are hollow dots or solid dots here, because one of them was hollow and one of them was solid, thus making this solid connection right here. I have the leeway to put either hollow or solid for one of them, just don't put it for both. I'll show you what I mean. So for the parabola, we know that it goes all the way to negative 3. So it's the x values that are less than negative 3 that are graphed. I could have put the equals to there, or I could put it in the next part, but I can't put it in both. We can't say it equals both. Then it wouldn't be a function. And this whole thing right here, the name of it says it's a function, and it has to be a function, so we can't overlap. We can't have 2 solid dots at the same place. For the absolute value graph, it starts from negative 3. It goes till it gets to positive 1. So that looks like this. And because I have a parabola that touches negative 3 and the absolute value graph that has negative 3, one of these has to have an equal sign underneath it, and it doesn't matter which one. Okay, totally, as long as one of them has, you could have it either direction. Which is why it's not fun to grade, just because there's so many options that are actually correct. All right, the last thing is that horizontal line. It is graphed for all x values that are greater than 1. And you see we've got this connecting value here at 1, where the absolute value went to 1. The horizontal line started at 1. So somebody has to be hollow and somebody has to be solid, and it doesn't matter which one. So I'll throw an equals to for this guy just because I can. As long as one of them has the equal to and one of them doesn't, we're good. All right, the bottom four is review of what we did yesterday. Hopefully those graphs aren't too bad, but try to finish this up. Hopefully you have a great weekend. I'll see you guys Monday.